Ever puzzled over how networks can aid in modeling flow problems in mathematics? Stay tuned to unravel this mystery. Let's start with a simple question. What is a network? Picture a web of interconnected points. These points are known as nodes. The connections between them, those are edges. And together they form a network. Now you might be wondering, what does this have to do with mathematics or flow problems? Well, networks are extremely relevant in modeling these problems. They provide a visual representation of how different elements interact and influence each other. For instance, imagine a city's water supply system. The nodes could represent different locations, homes, offices, and parks, while the edges symbolize the pipes connecting these places. This network helps us understand how water flows from one location to another, and if there's a problem, where it may be occurring. Now that we understand what a network is, it's time to dive into the heart of the matter. Flow, capacity, sinks, and sources. Flow and capacity, two critical aspects of networks, but what exactly do they mean? Let's start with flow. Picture a river. The water rushing downstream is akin to flow in a network. It represents the amount of stuff. It could be water in a pipeline, electricity in a power grid, or even data over the internet that is moving through our network at any given time. Now think of capacity as the river's banks. It's the limit, the maximum amount that our network, much like the river, can handle without overflowing. So in essence, flow is about movement, about how much is going through, while capacity is about boundaries, about how much can go through. They work together, hand in glove, to ensure our networks function smoothly and efficiently. Flow and capacity, the lifeblood of a network. But what happens when there's too much or too little? Enter sinks and sources. Sinks and sources, the unsung heroes of network flow. But what roles do they play? Well, in the realm of networks, sinks and sources function as the key gatekeepers. Let's first delve into what they are. Imagine a network as a bustling city. Sources are like the entry points or gates into this city, where all things, be it cars, people, or data, make their way into the network. On the other hand, sinks are the exits, where these elements depart, marking their journey's end within the network. Now why are these important? They help maintain balance. Without sources, the city, or in our case the network, would be deserted, devoid of any activity. Without sinks, it would be chaos, with elements endlessly circulating without any exit. So in essence, sources are responsible for introducing elements into the network, and sinks ensure their departure, creating a smooth, cyclical process. Sinks and sources, the regulators of a network. Now let's bring it all together. So we've covered networks, flow, capacity, sinks, and sources. But how does it all fit together? Well, let's dive right in. These elements are not just mere mathematical concepts. They are essential tools used to model flow problems in the real world. Think about it. Traffic management is a classic example. Imagine a network of roads, where flow represents the number of vehicles. Capacity is the maximum number of vehicles a road can handle, and sinks and sources are entry and exit points. Understanding these elements can help us design better traffic systems to minimize congestion and improve efficiency. Or consider water distribution networks. Here, flow is the volume of water, capacity is the pipe size, and sinks and sources are water treatment plants and households. In data communication networks, these concepts help us manage data packets efficiently. And there you have it. Networks, the unsung heroes in modeling flow problems in mathematics. Until next time, keep wondering, keep learning.
Want to rise to your full potential in your studies and revise like a boss? You can trust Study Guide Today to have you covered. Subscribe to this channel and see our website linked in the description of this video to see revision articles to maximize your study gains.